Hi, I'm Luke from MLOps Consulting, and I'm going to give you a quick preview of a demo I'm working on for running lora with stable diffusion in Dagger. Dagger is a system for building pipelines as code that run anywhere, and in this case we've got the pipeline written in this Python file. So what we can see is that we are going to fine-tune stable diffusion on some brand assets and then generate some merchandise for those brands, mugs and t-shirts and so on. And the way that we do that is we download the brand assets, which I've uploaded to Google Storage here. We unzip them. And then we, for each of the assets, we run this command to fine-tune a lora, which is a small kind of diff of the weights that can be applied to the model to make this stable diffusion model learn how to make things look like Coca-Cola or Dagger or Docker or some of these other well-known brands. So the first thing it does is it fine-tunes the lora by running this script, and it takes the input as that specific brand for each of the brands. So it loops through the brands and creates a lora for each of them. And then it will also loop through the brands again, loop through, and for each brand it will loop through all the prompts, and then for each prompt it will make 3 different images or 4 different images based on different random seeds, so we can get like a range of outputs. And then for each of those it runs this Python script inside which pulls in the prompt, the seed, and patches the stable diffusion weights with the lora, which again is the input, and then the result is generated as an inference on the model, on the patched model, and then saved to a file that's named like this. And so you can see what we've done here is we've kind of systematized this process that would otherwise be very manual to try and do it on all of them. And that's what's nice about Dagger, is it lets you quite easily kind of set up these loops around these elements of the pipeline and then parameterize them all in Python code without having to really think too hard about pipelines. But it then creates these pipelines which have caching and which can be run anywhere, so you can run them on your laptop or any machine with a GPU in this case, or you could push them out to a production Kubernetes cluster to do this at scale. So that's quite interesting. So let's have a look at the system in action. I've already run it to generate some loras for Coca-Cola, Dagger, and Docker. Like I said, these loras are quite cool because they're only, let's see if I can show you. It doesn't actually show you how big the file is, but let me just show you here. So if we go into output and then the loras, then we look in the Coke one, then this one's only 800 kilobytes. Let's look at the Dagger one. This one, yeah, same. So they're tiny little files, but they contain kind of enough image to customize the model to images it hasn't seen before. And we've also, just to show you the actual brand assets themselves that we're training these models on. So for Coca-Cola, we've got images like this, pictures of bottles of Coke, another one here, and for Dagger we've just got screenshots of the Dagger website, so you can see this kind of stuff, and we've also got little snippets of some of the brand images that Dagger uses. Dagger uses this quite cool kind of sketchy style, so we'll get to see if the model is able to reproduce any of these inputs. I quite like these cool little guys. So without further ado, let's actually run the thing. I'll close these down to keep things sane. And so if we go up here and we do dagger run python ci/lora.py, then we'll see that it has already cached running these jobs where, let's see if we can see a bit more of it. Yeah, so it's already cached the jobs where it's reading in the brand assets and generating the loras. So that's pretty cool. And then it's going to start running these jobs which actually do the inference. So normally if you were running this script and you reran it, it would redo the training every time, but the training takes about 15 minutes. So it's quite nice that given that I ran the training before, it's quicker because it's automatically used the dagger cache to make things fast. So then let's see what it's doing. It's generating some outputs, some inference. So if we go and look at the Coke inference, okay, well, what did we ask it for? We asked it for a coffee mug with a logo on it in the style of whatever the style is. So I guess that looks a bit Coca-Cola-y. Let's look at some of the other ones. That's why we generate 3. Yep, kind of got plausible Coca-Cola vibes. That one definitely looks like a Coca-Cola mug. So that's pretty cool. Let's see about the t-shirts. So there we have someone wearing a brand new invention of a Coca-Cola-like t-shirt. There's another one. And there's a third one, which looks terrifyingly zombie-like, to be honest. But there we go. I mean, these models are only going to improve as they get more mature. And I think in July, SDXL 1.0 is going to get released, which will improve the quality a lot here. So that's, yeah, it was 3 of each actually. Let's go and see how the dagger ones look. Those are coming out now as well. Okay, well that's kind of interesting, that mug that looks a bit dagger-esque. That looks like a mug from above. And that looks like quite an interesting dagger mug as well. Let's see what the t-shirt ones look like. Interesting. I guess it bears some resemblance to the dagger logo. And we've got another one coming here now. Yeah, okay, slightly terrifying. Kind of weird. But I'm not here to I'm not here to convince you that I'm the best prompt engineer in the world or that I'm using the latest and greatest models, but I'm here to demonstrate kind of the workflow and the possibility here. Yeah, there we have it. There's a quick example, and I'll talk more about this in the Dagger community meeting next week. So thanks for watching.